Hello friends, and in this lecture we are going to discuss another type, that is type 7. Design the DFSM to accept the language containing multiple of 3, multiple of 5, anything, multiple of 5s in binary number. This is the here difference. This should be accepted in the binary forms. Means consider if you given the input here 0 0 0 0 in binary, that is represented as a 0. 0 0 0 1, that is 1. 0 0 1 0, this is 2. 0 0 1 1, this is 3. 0 1 0 0 is 4. 0 1 0 1, 5. 0 1 1 0, that is 6. 0 1 1 0, sorry, this is 1. So you can write it here 0 1 1 1, that is 7. 1 0 0 0 is 8. 1 0 0 1 is 9. 1 0 1 0 is 10. 1 0 1 1 is 11. 1 0 1 1 0 0 is 12. Similarly 1 1 0 1 is 13. 1 1 1 0 is 14, and 1 1 1 1 is 15. Up to the mark, this one you do it. Then which one should be the final state? This 0 should be the final state, because this is the multiple of 5. So this should be accepted. 5 should be accepted. 10 should be accepted, and this 15 should be accepted. So you write the number here A, B, C, D, E. Again this should be the same state, because this is the final state and final state is A here. So again we will rewrite as A only. Again we will start from B, C, D, E, and again A. B, C, D, E, and again A. So based on this we will do the third transitions. We will start with the starter state, and this is the first state A. Here A 0 0 0 0, it should be up to the A only. So we will make the loop here only and write 0 0 0 0, that should be the A only, and this should be the final state. Again 0 0 0 1 is 1, and that is B. So starter state 0 0 0 and 1, this should be goes to B. 0 0 1 0 is C. 0 0 1 and 0, that should be goes to C. Again 0 0 1 1, it should be goes to D. 0 0 1 and 1, it should be goes to D. Again 0 1 0 0, 0 1 0, 0 1 0 and 0, it should be goes to E. Again A 0 1 0 1, so starter state 0 1 0 and 1, this should be goes to A. Again 0 1 1 0, 0 1 1 and 0, it should be goes to B. Similarly again 0 triple 1 should be goes to C. 0 1 1 and 1, it should be goes to C. D is 1 0 0 0, 1 0 0 and 0, it should be goes to D. E is 1 0 0 1, 1 0 0 and 1 itself is E. So 1 0 1 0 is A. 1 0 1 and 0 is A only. So 1 0 1 1 is B. 1 0 1 1 1 and 1 is going to be B. Similarly C 1 1 0 0 1 1 0 and 0 is going to be C. So this is the DFA for the multiple of 5. This is already accepting everything. Consider this one want to accept it here. 4 1 should be accepted by these machines. So 1 1 and 1 and 1 it is accepting here. So this is how you can design the multiple of binary numbers. You can design up to the 15th numbers, and based on that you can design the A, B, C, D. Similarly, if you given is consider if you given multiple of 4 is given, design the DFSM to accept multiple of 4 in binary number. So we can design it here like 0 0 0 0, this is 1, 0 0 0 1 is, this is 0, this is 1, 0 0 1 0 is 2, 0 0 1 1 this is 3, 0 0 0 1 0 0 is 4, 0 1 0 1 is 5. So you can write this should be accepted, this should be accepted. 6 0 1 1 0 6, 0 1 1 1 7, 1 0 0 0 this is 8, 1 0 0 1 9, 1 0 1 0 is 10, 1 0 1 1 is 11, 1 1 0 0 is 12, 1 1 0 1 is 13, 1 1 1 and 0 is 14th, and 1 1 1 1 is 15th. So you can, this should be accepted. This is A, this is B, this is C, this is D. Again this should be the A only because this is accepting the final state. B, C, D, again A should be accepted. So you can write rename as a only. B, C, D, again 12 should be accepted. So A, B, C, D, and again next one should become accepted. So you can write it here, start state Q0, yeah, A you can write it here, and 0 0 0 0 should be in the A only. So you can write loop here, 0 0 0 1 is B, 0 0 zeros and 1 is going to be B. C is 0 0 1 0, 0 0 1 and zeros is going to be C. 0 0 1 1 is going to be D, 0 0 1 and 1 it's going to be D. Next 0 1 0 0 should be is going to be A, 0 0 1 0 0, 0 1 0 and 0 is going to be A. So 0 1 0 1 is B, 0 1 0 and 1 is going to be B. 0 1 1 0 is C, 0 1 1 and 0 is C. 0 1 1 is D, 0 1 1 and itself 1 is D. 1 0 0 is 1 0 0 0 is A, 1 0 0 and 0 is A only. So this should be the final state here. Again you can check for any number. 1 0 0 1 should be going to be B, 1 0 0 and 1 is going to be B. Again you can check for this A should be accepted, 1 1 0 0, 1 1 0 and 0 is going to be accepted the final state. So this is the DFA for the multiple of 4s in the binary number. So this is how we can design this DFA to accept the binary number in multiple of 4s. Now another is we have is topic is non-deterministic finite machine, finite state machine, also called as NDFSM. So this machine also having the NFA is collection of 5 tuples. This machine also having the same Q, sigma, delta, Q naught and QF. This Q is called as the finite set of a state. Summation is the input, delta is the transition, Q naught is the starter state, and QF is the final state. So this is the NDFSM. Now we will see some important points for the difference between the DFSM and NFSM. So here the big difference between the DFSM and NFSM is DFSM, and this side I am writing as a NFSM. First one is DFSM and different is every input strings leads to the unique state of finite automata. This is the main difference between the of DFSM. Each input, like I'll say this is the Q naught you have designed, so A have to write it here, yeah, B somewhere is going. Every state you have to show where is going A, where it's going B. But in NDFSM is not necessary. For the same input, there can be more than one next state. So just you can assume here NDFSM is just like your temporary, just like a rough structure. Rough structure means like consider machines you have designed, and maybe you have this machines is not accepting for the every input as you constructed for the particular machines, then it is called as NDFSM. But DFSM is the particular perfect machines. That is the main difference between the NFSM and DFSM. Second difference, you can write it here: conversion of regular expression, which we will study regular expression in the next modules. Conversion of regular expression to DFA is complex, but here regular expression can be easily converted to NFA using any Thompson's construction. This is another method we will study in the next units, Thompson's constructions. This is the main difference between the NFA and DFA. Another more difference you can write for the DFSM and NFSM is third one: DFA required more memory for storing the data, storing the state informations. And another way, NDFSMs required more computations, to match the regular expressions with input. Fourth difference, you can write it here: the DFA is not possible to move. The DFA is not possible to move to the next state without reading any symbols. In another way, NDFSM can move. NDFSM can move to next state without reading any symbols. So this is the main four difference between the DFSM and NDFSMs. This is usually asked in the B2 University for the 4 marks, 6 marks. So this is the theory topics, and you can remember for this. Another questions maybe comes in based on the NDFSMs. Conversion of NDFSM to DFSM. This is the important topics, and this is very asked for the 6 marks as per B2 syllabus, and we'll design some NDFSM conversion to DFSM. So here the first question is given here. First question is given here. Define NFA and convert the following NFA to DFA, DFSM. And the question is given here. Q0 is 0 is going to the Q0 only, and 0 and 1 is going to be in Q1, and Q1 is the final state, and 0 and 1 is going to be Q2, and Q2 itself is looping on. So this is the question is given here, and you have to convert in the DFSM. Define NFA, NFSM you can define as in the last few minutes back I have defined 5 tuples. You can define it here. Now I am going to teach you the conversions here. So conversion, you can write it here state, the truth table, delta, this is transition. Input is here 0 and 1. This is the input here. The start state is Q0. Q0 you write in the for bracket because this is the start state, and always you have to merge it, so always you write in the bracket floor bracket. Q0 to 0. Q0 to 0 it's going to be Q0 and Q1. So you have to write it Q0 and Q1. Q0 to 1. Q0 to 1 it's going to be only on the Q1. So if in this two state, if anything new is there, you write it here. Like consider Q0 and Q1 state is the new, and Q1 also is the new. If Q0 come, Q0 is already there, no need to write. But Q0 and Q1 is the new state, and Q1 also is the new state. So we will write both here, Q0 and Q1 and Q1. If anything new comes here, you write it down. Now you check out Q0 to A, union Q1 to 0. Sorry, Q0 to 0, union Q1 to 0. So Q0 to 0 is Q0 and Q1. So you write it here, Q0 and Q1. Q1 to 0. Q1 to 0 is Q2. So union means combine both, so you can write it together itself. Now Q0 to 1. Q0 to 1 is going to be in the Q1, and Q1 to 1 it's going to be in the Q2. So check out in this two any new state is there? Yes. This is also new state. Q0, Q1 and Q2 is the new state. And here even Q1 and Q2 also is the new state. Now we'll check for the Q0 to 0, Q1 to 0. Q1 to 0 is going to be on the Q2, and Q1 to 1 it's going to be again on Q2. So any new state comes? Yes, this is the new state, that is Q2. So you have to write it here. Yeah, I will write it here. This is delta, this is 0, this is 1. I will write it here. Q2 is the next state. Next, Q0 to 0 you check out, union Q1 to 0, union Q2 to 0. Combine all. Q0 to 0 is Q0 and Q1. So I write it Q0 and Q1. Q1 to 0, Q1 to 0 is Q2. Now Q2 to 0 is nothing is there, so this much is the input. Q0 to 1, Q0 to 1 is going to be in Q1. Q1 to 1 is Q2, and Q2 to 1 is itself Q2. So any new state comes, Q0, Q1 and Q2 is already there, no need to write once again. Q1 and Q2 again, this is already there, so no need to write. Again we will see for the Q1 to 0. Q1 to 0 is going to be on Q1 to 0, it's going to be in Q2, and Q2 to 0 it's nothing here, so it should be as it is on Q1 to 1. Q1 to 1 is going to be on Q2, and Q2 to 1 also is on the Q2 on. So Q2 is the new state. No, Q2 I already have written, so no need to write once again. Now Q2 to 0. Q2 to 0 is nothing, so nothing is there, means you can write it 5, and Q2 to 1 is Q2. So this is your DFA. Now rename, you can write it here. This is A, this is B, this is C, this is D, this is E, and this is F. So this is also should be B, this is C, this is D, this is your E, Q2 is your F, and this is your D, Q1, Q2 is E, Q2 is F, and F. This way you can construct the DFA. Now we have to write the DFA. So I'm going to erase these questions here which I have written here, and I will design here only the DFSMs. Here starter state is A. A to 0 it's going to be B. A to 1 is going to be on C. B to 0 is going to be on D. B to 1 is going to be E. Here you can assume here E. C to 0 is F. C to 1 is also F, so you can write it here. D to 0 is D. D to 0 itself is D on. D to 1 is going to be in E. E to 0 is F. E to 1 also is the F. F to 0 is nothing. F to 1 is F1. So final state will be what? In the question the final state was in Q1. You check out in the set which having the Q1, all will be the final state. Like this set we have in the Q1, so this should be a final state. This should be a final state. This also having Q1, this should be the final state, and this should be the final state. So your B, C, D, E is the final state. B, C, D, and E should be the final state. So moreover, you can check out in these questions this F all having the in degree. There is nothing going outward. So more you can design it, more minimizations with the study. You can delete this F, but here not required. Here not required. You are already converting to NDFSM to DFSMs. So this is the final state. The final answer you can write it here. For the minimizations with the study, you can reduce this 1, 2, 3, 4, 5, 6 state to some more less state. We will see in the minimization of the DFA. We will see one more problem based on this. And here is the questions. Another convert. Second questions. Convert this NFSM to DFSM. And the question is given here Q0. From 0 it's going to be 0 and 1 is going to be in the Q0. 0 it's going to be in the Q1, and 1 is going to be in the Q2. And this is the final state. So now again same we'll do it here. Delta 0 is the input and 1 is the input. The start test state is your Q0. Q0 to 0 it's going to be Q0 and Q0 and Q1. Q0 to 1 it's going to be only in the Q0. Any new state comes? Yes, this is the new state, so I will write it here, Q0 and Q1. Q0 to 0, Q0 to 0 is Q0 and Q1. Q1 to 0 is nothing here, so this is only. Q0 to 1 is Q0 and Q1 to 1 is Q2. So any new state comes? Yes, this is the new state, so I should write it here, Q0 and Q2. Q0 to 0, Q0 to 0 is Q0 and Q1. Q2 to 0 is nothing here, so this much will be there. Q0 to 1, Q0 to 1 is Q0 and Q2 to 1 is nothing here, so this much. Any new state comes? No. So this is Q0 and Q1, this is already there, and Q0 also is there, so no any new terms here. So we'll write just a rename A, B and C. So this is the name is B, this is A, this is B, this is C, C and A. We'll design the DFA here. A to 0 it's going to be B, A to 1 it's going to be A itself, B to 0 it's going to be B, B to 1 it's going to be C, C to 0 it's itself in the C only, and C to 1 is A. Which is the final state? In this question the final state is Q2. So the set which having the Q2, it should be the final state. Here no Q2, here no Q2, this state having the Q2, so this should be the final state, means C should be the final state. So this C should be the final state. This is the NFA, this is the DFA for the corresponding NFA. Thanks for watching.